I'm Anil Kumar. Welcome to my channel, which you trust for finding the best solutions to your questions. Here is another very interesting question from one of our subscribers who wants to know the solution of this trigonometric equation. In fact, there were two. The second one, I'll take it in the next video. Now, in the same set of comments, I had also a comment from Mr. Rahul, who had the true concern, and which is also my concern. The question which Rahul poses is, for whom am I making these videos? Since there are only 20 hits on this video. Well, that's true. Very few people watch my videos, but I'm grateful to those who watch and suggest and also contribute with this rich collection of questions. And even if one person gets some help, I'm happy about it. My day goes so well. I really love it. Now let's look into the solution of this particular trigonometric equation. 16 sine to the power of 5x plus 2 sine x equals to 12 sine cube x in the domain 0 to 2 pi. So I don't really have an equation like this, and so thanks once again for posting it on my channel. So let's see how to solve it. Let's bring it to one side. So we have 16 sine to the power of 5x minus 12 sine cube x plus 2 sine x equals to 0. Now we can take 2 sine x common, right? And what we get here is 8 sine 4x power, that is 6 sine square x plus 1 equals to 0. Now this could be factored. We're looking for a product of 8 and sum of minus 6. 4 times 2, both negative. So we get 2 sine x, 8 sine to the power of 4x minus 4 sine square x minus 2 sine square x plus 1 equals to 0. So it gets to sine x. We can take 4 sine square x common. So we get 2 sine square x minus 1. Here we have minus as common, so we again get 2 sine square x minus 1 equals to 0. So we get 2 sine x and 2 sine square x minus 1 is a common factor, giving us 4 sine square x minus 1 as the other factor. So that gives you 3 solutions, right? So one is that 2 sine x equals to 0. So that gives you when sine x is equal to 0, correct? We are talking about the domain between 0 to 2 pi. So let's try to understand that also. So here's a sine curve. In the domain 0 to 2 pi, whose solutions sine x equals to 0 will have 3 solutions, correct? So which is at 0, pi and 2 pi. So we get these 3 solutions, 0, pi and 2 pi for x, correct? Now the next factor here is 2 sine square x minus 1. So let's write this, 2 sine square x minus 1, that means sine square x, we want that to be 0, right, is equal to half, or you can say sine x equals to plus minus 1 over square root 2. We could use special triangle for this solution, which is pi by 4, correct? So if you use this pi by 4 special triangle, then we get 1 over square root 2. Since we are talking about plus and minus, that means we have 4 solutions, right? So we have solutions in all the 4 quadrants for acute angle pi by 4. Right? So what you find here is 4 different solutions, and that gives you as x equals to pi by 4. So it is like this pi by 4, then we have 3 pi by 4, 5 pi by 4, and 7 pi by 4. Clear? Okay. Now the third part is, let's do it here. We have 4 sine square x minus 1 equals to 0, or we get sine x equals to 1 over 4, and then again we'll do square root with plus and minus. So that gives you plus minus half as your solution. So for plus minus half, you could use 30, 60, 90, So we're looking for sine x equals to plus minus half, correct? So the triangle which we are looking for is 30, 60, 90. So these special triangles really help, so that you could straight away find solutions without using a calculator, right? Sine, that means we're looking for pi by 6 angle, correct? Again, plus minus. So that means 4 different solutions. So we get x equals to pi by 6, and then we have 5 pi by 6, 7 pi by 6, and 11 pi by 6, correct? So these are all the solutions. So that is very interesting. So how many solutions do we have? We have a lot of solutions in this particular case. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 solutions. So all these are part of our solution. So as far as the answer goes, you write all these values. Does make sense, right? So we have 11 solutions to this particular question. So I hope you really find it interesting and useful, and it helps. Feel free to post your questions, share my videos with your friends, and I hope someday these viewers, the numbers will increase also. Thanks a lot.